Hello there. Welcome. Welcome to this video in the Arvest machine learning tutorial series. This will probably be the last video in this current series, probably with more coming along soon, but this is certainly the last one that I will be recording in regard to this first set. So what we'll be doing today, I hope will be interesting to people. So I should be inserting some images of the kind of thing that we're going to be hoping to achieve by the end of the video. We're going to be looking at how we can start viewing, creating and viewing interactive network analyses of data that is found in Arvest and navigating data that is in Arvest via network visualizations. So in this example, you'll see that the network I've actually created is a visualization of files on my computer, basically. Let's get started, because there are going to be a few moving parts to this, so we should try and get on. So we're going to head over to the Arvest website and the API and ML tab, and we're going to go to machine learning, and we're going to open up the the ML notebooks repo that we can find here. So we're going to go down to the ML workflow tutorials, and so we're actually going to be looking at both of these two notebooks today. So as it stands currently, there is no Colab version of the what I've called the folder to IIIF manifest collection notebook. That is because basically it the idea is that it's a notebook that will take a folder on your computer and create a manifest for each file that's within that folder, and this makes a bit less sense in an online setting. So I mean, essentially it could work. It would mean uploading to the Google Colab space all the folder that you wish to analyze and all of its content. But yeah, it makes a bit less sense in terms of the different things that we're wanting to extract and all that kind of stuff. But anyway, yeah, so we will be using the local version of that, and then we'll be looking at the basic network analysis notebooks. So that does exist in a Colab form, but again, we'll be using the local version because it's a bit quicker. So let's get started. So I've gone ahead and already cloned this repo and got it ready to go here in Visual Studio Code. If you need help with that, then you can look at the first video in this ML part of the tutorial series, which gets you started with that. So first step, we're going to come into workflows, and we're going to open up Corpora and this file corpus folder. So you'll see three files in that, and we're going to open up this Python notebook. So what's going to happen here? So this is like a preemptive step to have a corpus that we can visualize in Arvest. So what we're going to be doing, we're going to be turning a folder of files on our computer into a corpus. We'll gather information about each file, create a IIIF manifest for each file, and then upload them to Arvest. So let's start by running our mandatory grotesque and ugly setup cell, which is creating a clean install for all of the various packages that we're going to need, and then importing them. So we've got our Arvest API package, we've got Arvest tools and other utility functions, and we've got our IIIF Prezi 3, which will allow us to create IIIF manifests, and we've also got the pillow image drawer for creating images, which we will also need. And we've created a temporary folder here, which will contain all of our temporary stuff. So what we need first to begin is a folder of content that we'd like to analyze. So I have on my computer a folder called in sound called projects, I believe is the one I put in here. But it could be anything. I mean, that's quite a small corpus. I might go for something bigger. Let me have a look. Maybe this max 8 packages file. That's going to be a bit big. Oh, what the hell? Let's go for it. So let's copy the path to this folder. So I'm going to copy it as so option click to copy the file path to this folder, and I'm going to drop it in here. There we go. So what I'm doing is I collect all of the files that are within that folder, and then I'm going to create a list of all the information here. So I am going. So as when you get this notebook, it will have this second boolean here as false. Basically, this gives you a choice to choose private information or not. As I'm going to be uploading this to YouTube and stuff, I will set this to true so that none of my private information gets out. Basically, it's things like hashes and stuff, which doesn't need to be that private, but it's probably best not to kind of just brandy about this kind of information. So I'm going to set that to true for the moment. And I'm going to press play. So here we go. We are collecting information about the files in my documents max 8 packages. So max 8 is a creative coding program that you may or may not have heard of, and packages is like the third party plugins that you can add to max 8. So this may be quite big, so this may take a little while to get. Yeah, 16,185. Yeah, that's going to be too big for these purposes. I think I'm going to just take yeah, let's just take one of the packages because that's just going to be too much. It's going to take too much time. So let's stick that in instead. Yeah, 5. That's still quite a lot. To hell with it, let's just do it. So we're going to go with 543 files as our corpus. So this is quite a big corpus. And just to check so that we see that things are working, we've gone ahead and gathered this kind of information about our files. And now what we're going to do is we're going to create some media. Because basically, we want to upload something to Arvest that will represent each of these files. But as you probably know, in IIIF, every manifest needs a media file as its kind of base. Typically an image file. There are instances where, for example, XML data has been passed into Mirador and things like that, but it's not truly kind of like officially IIIF compliant. So we're going to be creating an image for each of our files, which will serve as a base for our IIIF manifests. And to do that, I mean, I won't go into the whole detail about what's happening in here, but basically for each of our files in our list, we are creating an image using, so where is it? HTML to PNG, which is a little help function that I have created and allow you to use here as part of my utilities thing. And basically what that does is it takes an HTML file. So I have this HTML file here, which is an HTML template, which can have style and, you know, all that kind of stuff. And you can also set a number of basically variables to be replaced. So it basically works with a ampersand, and then the name of the variable, and that can be replaced with whatever you like, basically. And the HTML to PNG will render that this HTML file as an image and save it as an image. So it'd probably be simpler if I just go ahead and run the code. Base name. Yeah, that's because during testing it needed the sensitive information to. Okay, so basically I'm going to set that to false and not care about sensitive information and just let people see all of the sensitive information on my computer. But so here you see that it is currently creating an image file for each of the files in that folder, and we can start going ahead and looking at them. And you see that we have one here. So yeah, there's no sensitive information in there, so that's not too bad. So we have this blobs.json. So it's filled up the HTML, you see, with the file name, and then location has been replaced with the location here, and yeah, it keeps all the kind of styling and things like that. So that is all doing. So it'll take a few minutes to compute because there's quite a lot of files, but once that's done, I shall get back with you. So there we are. We have successfully created an image file for each of the files that was in that folder, with some information about the different files. Just seeing that the MIME type didn't seem to work for PNG, which I'm not sure why, but anyway, you get the idea. And we also kept hold of the media data, which is the locations of different elements within the media, which I don't think we'll actually be using for our visualization, but it can be useful to have if you want to make these visualizations interactive. And our file data, which I won't show on the screen because that's got all kind of like hashes and all that kind of stuff in. Yeah, so now that we have these images, we need to upload them to Arvest. So to do that, I'm going to connect to my Arvest account here. So if you've been following these tutorials, you'll know this cell very well. We're creating an instance of the Arvest package and then connecting up like that. And then we are going to add each of these images to Arvest. So we're iterating through our file data. We are printing our process just so that we know where we are. And we're adding up our media using the add media function, giving it a new title and description, and giving it some metadata as well. So I'm going to set that running, so it'll take a couple of minutes and I shall get back to you once it's done. But just so that you can kind of see what's happening, if I go back to Arvest and I connect to my account in my media, you'll see that so this is beginning to start populating, and you can see, for example, that this image has been uploaded to Arvest. But yeah, so that so about 500 files. It's going to take a couple of minutes, so I'll get back to you once it's done. There we go. So we are now 100%. Everything has been uploaded to Arvest. So you'll see that we've got now 56 pages of media, because there are about 560 files from what I believe, each of them representing a different file that we had in our folder there. So bear with me. I mean, you know, this may appear quite opaque at the moment, but there is a reason behind all this madness. So the last thing that we want to do is actually create a manifest for each of these files. So basically, we're going to take each of the files that we had in our file data, and we're going to So use the media to manifest item here in the Arvest Tools helper package, and take the media item that we get through some clever parsing here and create a manifest straight from that. We're going to add some metadata to it. So the metadata is actually taken from the file info that we got at the very beginning. Now I'm just going to add off camera a few conditions so that it doesn't add some private information. I'll do that now and come back to you in just a sec. Right, there we go. So I just added this condition not to add these things. I'm not sure if this is really sensitive stuff, but I don't know, probably best not to give out everything about my computer anyway. So yeah, for each of the other files in our file data, we're adding a metadata field, and then we're updating our manifest metadata according to that. And then we're just saving the manifest file, and we're adding the manifest to Arvest, and we're just changing things like title and description, and again some of the metadata content so that we can find it again when we need to. So I'm going to go ahead and click play on that. And yeah, so I'll get back to you in a couple of minutes, because this is again going to create a manifest for each of the images and files that we created earlier. So it'll take a couple of minutes to process for the 500 files, but I shall, so you can see that should be able to see that things are getting added. I'm not seeing them here. Oh yeah, there we go. So they are progressively getting added, and if we open one up, for example, we can see that we now have our image as a IIIF manifest, and we can have a look at some of the metadata, which is down here, which is giving us some information about our file. But yeah, I will get back to you once that has been performed for the 500 different files. Okay, so we are now done. So we have got a whole load of manifests uploaded to Arvest. There we go. And now that has basically created us a corpus that we're going to be able to use to visualize in a network visualization. So we've finished pretty much. I mean, we'll keep this open because we're going to want to clean things up later. But we finished pretty much with the file corpus notebook, and we're going to now go ahead and open the network analysis, basic network analysis corpus. So this is going to take stuff that we have uploaded and hosted on Arvest, and it's going to parse their metadata and things like that, and use that to create a network visualization of this content. So we shall start again by running this setup cell. So once again, we're having a clean install for the various packages that we're going to be using. So Arvest API, the Arvest API tools, and most importantly, Network X, which is what we're going to be using to create network data in Python. So sorry, it's 20 past 1 and I still haven't had my lunch yet, but yeah. Anyway, we shall soldier on. So first of all, we're going to be getting the manifests that we want to use. So once again, I'm going to connect to Arvest like that. Then I'm going to get all of my manifests and check if they have the identifier folder to corpus, and that will serve as my corpus. So we created these networks from files on my computer just to kind of demonstrate how this could work, but these could actually be manifests, any kind of manifest that you have on Arvest that you would like to visualize in a network. It's just that this was a way of having quickly getting a network of data that can be visualized in interesting ways. So we're going to run that. And it's iterating through all of the manifests. Excuse me. And each time it finds a manifest that has this metadata, we're going to be appending it to this network content list. The idea being that each manifest here is going to be a node in our network. So I'll just let that complete, and then we shall come back once it's done. There we go. So we've got 520 manifests. So we haven't got quite the amount of manifests we had at the very beginning. That's because there was a bit of an error in uploading some of the manifests at the end. I didn't bother restarting the process because this is just for demonstration purposes, and 520 manifests is quite enough to show an interesting network. So we're now going to be creating the network from these manifests. So we're going to be keeping track of a dictionary of nodes, and we are going to create an instance of the network X graph class, which will be our network. And then for each of the manifests that we found, we will be adding a new node. We'll be creating an ID, so a UUID, so a unique identifier for our node, and we'll be adding to our node dictionary at the address of our ID, the manifest file and its content and all that kind of stuff. And we'll be adding our node to the network. So we shall do that very quickly, shouldn't take too long. And the reason why this is not as quick as it could be is because each time, so we're adding the manifest object, which is the instance of the manifest within Arvest, and we're also using the get content so that we straight away get the JSON data of the manifest that's associated with it. So there's a bit of computing for it to do, but it shouldn't take too long. There we go, so it's about 45 seconds, and then we're going to be adding a few more nodes to our network. Basically, we're going to go through our nodes that we've already added, and for each time we find a new folder that each file was created in, we're going to create a new node in the network, which is a folder, represents a folder. So that shouldn't take long at all. Yep, so we found 187 different folders within our network. So now we can display our network within our notebook just to see how things are getting on. So for this we've created a few utility functions. So this is a display network which will use matplotlib to actually show network data. We can also use a layout algorithm to change how that gets laid out, but we'll go to that in a second. And we can also have labels if we want to label things. So let's run that and see what this looks like. So obviously at the moment it's covered in labels, so that's not very useful. So perhaps I shall tell it not to display the labels actually, because that's not going to be very useful for us. So I'm going to run that. There we go. And so there aren't any edges, there aren't any links between nodes, so all of the nodes are just kind of splotched in a circle within the network. We're next going to add edges so that this actually makes a bit more sense. So to do this, I mean, there are various ways that you could add links between different nodes according to the kind of things that you're trying to inspect and extract from the data. What we're going to do basically is create links between a file and the node that represents the folder it was found in. So we're going to do that, and then we're going to display the results. So here, so this is obviously quite a low resolution visualization from using matplotlib, but this is in fact I don't know if I can actually zoom into that, or yeah, this is not something that I often do. Yeah, no, probably not, apparently. But yeah, you can see that things are looking already a bit more organized, and we can see that there must be different kinds of folders with different content, and we're beginning to be able to extract some information about this network. So as I said before, we can choose different layout algorithms. So we could choose a circular layout, which will give this interesting kind of shape. I mean, you can explore different kinds of layouts and how they will make the network stand out. But we'll just keep the kind of traditional Spring layout algorithm for now. And now we're going to export things to Arvest. So what we're going to do first of all is we're going to create a high-res image of our network. So I'm going to start by using this, but I may change this in just a second because it may not be high resolution enough. Let's have a look. Yeah, it's probably not good enough quality. So what I'm going to do is so this is using a utility function that I provide called network to image, which takes a network X image and then create graph and then creates an image from it. I'm actually going to make this 10,000 by 10,000 pixels. Let's see what that gives us. So node color and node outline color we're not going to change, but we may change things like width and things like that. So we can now discern between different nodes, but we might want to make them slightly bigger, or not. Let's not bother. That seems okay. So basically it min-maxes. The size of the node depends on the number of neighbors that it has. So if I open the image again, you'll see that, for example, these nodes here in the middle are a bit bigger because they have more neighbors than these other nodes. Let's maybe make them a bit bigger because so it linearly min-maxes using this the things that you give here. So I don't know, let's make the biggest size 100, for example. Let's see what that looks like. So it's quite a big image, so it takes a few seconds to create. And now, how does that look? Yeah, it's possibly a bit more readable. But yeah, okay. So we'll go ahead with that, and then we'll upload it to Arvest. So this is using the add media function and all the same kind of title, description, updating, metadata, all that. So we shall add that. As such, it has been uploaded, and then we shall use the Arvest Tools Media to Manifest function, which we've been using a lot in this tutorial series, that will take this media that we've just added and create a manifest from it. And then for each node we have in our node dictionary, we are going to create a textual annotation using Arvest Tools to add textual annotation helper function, which will add a new annotation to our manifest, where we can give the X, Y, width and height position of the node, which we can keep computed because that gets returned to us from by this network to image function. And we can also link it to the manifest that it's supposed to point to, which is the manifest that we created in Corpus Creation earlier. And we'll also give it some textual content, which is just going to be the file name of that node. So we are going to go ahead and do that. That has been created. And now finally, final step, we are going to save that to disk. Then we are going to upload the manifest to Arvest, and using the get preview URL function, we're going to be able to get the link to it and start exploring. So if we click on that, so this will take a few moments to load up because it's quite a big image. There it is. So we see that we have, yeah, I'm starting to regret maybe some of the colors. Oh, maybe if I put my sorry, that's not what I'm wanting. If I put my workspace in dark mode, yeah, that's going to be a bit more visible. There we go. So we see that we have our network visualization, which is here. If I turn my annotations on, we see now that, so they won't actually be interactive because it's only for specific files that I've created annotations. These must be folders. But so if we go away from that big mess there, maybe we can have a look here. We can have a look at this. We see that they've been linked to another manifest. So it should be the Constanzo prepared snare m.wave file, and so I can open that in a new pane here, and we can see what else. We can see this delay line file, which is here, and I'm assuming that they are both they're both in the media file, so they're both there, and so that's we've managed to explore our network in that way. I can zoom in over here, for example, and see, so this seems to be quite a big folder. So what are these files in here? So this seems to be, so I know this folder of files because I use this Max package quite regularly. But so these are the help files basically for each thing. But yeah, so we can see that we now have this interactive network visualization of this corpus of files that we had within Arvest. So this is obviously quite a simple way of looking at things, and not necessarily the most useful thing, although it can be useful to be able to go through things like this. Where it could get useful is perhaps this could be one state of your project, and which you upload in this state, and then you could continue working on it and then add and then redo the process, and you can see the differences between things. And with a bit of imagination, you can really create some quite powerful interfaces. But yeah, this was just kind of the basic way in, so that you can start seeing how things are working. So all that we need to do now is clean up what we've done. So we're going to remove this temporary folder here, and I'm going to remove that temporary folder there. And then remove the things from Arvest. I'm going to do that now because I'm not going to keep those 520 files within my Arvest, but this is stuff that we've done before. So basically just getting all of our manifests, seeing if it's something we created here, and then removing it. So yeah, that is it for this tutorial. I hope that was useful. I hope it perhaps could inspire you to, hopefully it'll show you how Arvest can be implemented in this kind of approach for network visualization, and being able to take our documents and manifests and start processing them as a collection rather than individual files, and then being able to create manifests which have this perspective over the whole collection, and being able to create interactive perspectives and interfaces that allow us to navigate this collection as a network. So that is the end of this series of tutorials. I expect more will be coming in the future. A quick note, perhaps, some of the ways that the API work and Arvest works will certainly be modified at some point, because Arvest is still a work in progress. You will have noticed that the API the GUI is still quite primitive at this point. But hopefully things shouldn't move too much, and these tutorials should still be useful whatever happens. But yeah, if you have questions, don't hesitate to ask in the comments below. If you have requests perhaps for certain types of process that you would like to see explored in this way, then you can also make some suggestions. And yeah, links to all of the things that we've been seeing today should be found in the description below. So thank you very much for watching. I hope it was useful, and I shall see you again soon.